Hello and welcome. Have you ever wondered what really goes on during the first day of university coding class? Well, today we're going to find out. We're going to step right into a virtual introductory Java lecture to decode the key lessons. And it's not just about the code, it's about learning a completely new way to think.
I mean, really think about that question. Because that's the big promise here, right? We tend to think of coding as this super technical skill, all ones and zeros. But what if its real power is actually in rewiring the way you solve problems? That's what we're here to explore. All right, let's get into it. Section 1, your first day coding. We're going to unpack the absolute essentials that a student gets hit with right from the very beginning. And, just like any new adventure, the first thing you do isn't taking a huge leap. Nope, it's about checking the map. Every class starts with the basics, the syllabus, the simple nuts and bolts that lay the foundation for everything that's coming next.
Okay, Section 2, the rules of engagement. Let's dig into the course logistics, the how, the when, and most importantly, how everyone's work is actually graded. So, right off the bat, the ground rules are crystal clear. Everything you need, notes, recordings, you name it, lives on the Moodle platform. The language is Java, which the instructor points out is one of the most essential. So you know right away, this isn't just theory, you're building real industry-level skills. Oh, and attendance? It's not a suggestion, it's strict. The message here is simple. You got to show up and be part of it. Now, this is where it gets really interesting for me, the assessment model. Notice anything missing? There's no single high-stakes final exam that decides your fate. Instead, it's all about continuous work. You've got weekly exercises just for practice, to build that muscle memory. Then there are formative check-ins to get feedback. And it all leads up to a final project that's simply pass or fail.
And this setup completely flips the script on the student experience, doesn't it? The point isn't to cram for one terrifying test. It's to build a skill piece by piece, week after week. It really lowers the anxiety, but at the same time, it raises the importance of staying engaged the whole way through. It's a marathon, not a sprint.
All right, Section 3, a new way of thinking. So we've moved past the logistics, and now we're getting into the philosophy of it all. The real why behind learning to program.
And this quote, this is it. This is the heart of the entire lecture. The instructor is basically saying, look, you're not just learning to type Java commands, you're learning a method, a way to take a big, messy, complicated problem, break it down into logical pieces, and then build a solution from the ground up.
I love this analogy. It's just a brilliant way to picture it. Imagine someone hands you this giant, complex, weirdly shaped cube. That's your problem. And then they point to this small, simple, perfectly square space. Those are the rules and constraints. Your job as a programmer is to figure out the logical steps to reshape that messy cube so it fits perfectly into that simple space. That puzzle, that is programming.
Okay, on to Section 4, your first programming toolkit. So, you've got the right mindset. Now, what are the actual first tools and concepts a new student gets?
The journey kicks off with these 3 big ideas. First up is the algorithm, which is really just a fancy word for a recipe, a step-by-step plan. Then you have syntax. Think of it as the strict grammar and punctuation that the computer needs to understand you. And number 3, my favorite, is debugging. Because you are absolutely gonna make mistakes, and learning how to find and fix them isn't a failure. It's one of the most important skills you'll learn.
So if we dig a little deeper into that recipe, it's basically made of 2 parts. On one hand, you have your statements and variables. Those are like your ingredients and your basic cooking instructions. But the real magic, the part that makes your program smart, comes from conditionals and loops. This is the logic that lets your program make decisions and repeat actions, turning a simple list of steps into something powerful.
And where does all this coding happen? It happens in the IDE. For this class, that's a program called Eclipse. The best way to think about an IDE is like a digital workbench. It's the one place you go to write your code, get hints about the syntax, hunt down those bugs, and finally run your program to see it come to life. All right, let's wrap this up. Our final section, the next essential skill, we're going to pull all the big takeaways together and end with something to chew on. To make sure students actually succeed, they're given a whole support system. You've got Moodle for all the official class stuff, you've got Eclipse, which is your main tool, and they even recommend a site like W3 Schools, which is a fantastic online library for when you just need to see another example or get a quick refresher.
And at the end of the day, this is the lesson that really matters. The specific syntax for Java might change one day, the tools will definitely get an upgrade, but this core lesson from day one, it's timeless. You're not just learning to code, You're learning a powerful mental framework for solving pretty much any problem.
So I'll leave you with this final thought, which comes straight from the source material. We're starting to accept that understanding code, this kind of logical problem solving, is becoming a fundamental skill, a new kind of literacy. But that makes you wonder, right? If this is today's literacy, what's the next essential skill that we're all going to need to learn to navigate the world that's coming? Definitely something to think about.